All right, guys, so this is 8.2 honors and 6.2 math 7. We're going to draw inferences from data. Okay, so our essential question for this is, how can you use data gathered from samples to draw inferences? Now, the first thing I want to go over is our vocabulary, and I'm going to try to go through and show you what this vocabulary means based on this data right here. So if you can see these numbers, we got 12, 15, 15, 18, and 20. We may be talking about different ages of people, whichever. So the range is the difference from the lowest to the highest number. In other words, I already put this in order. Anytime you have data, you want to put it in order. So all we're talking about here is I would take the highest number, 20, and subtract the lowest number, 12, and that means that our range is 8. In other words, from 12 to 20 is 8. So the correct answer for this one, for our range, is 8. Okay? So I'm going to go through each one just like this. The mean is our average. That means we have to add all 5 of these numbers and then divide it by 5. In other words, I'm going to take 20, oops, I wrote 12. Let's go 12, 15, 15, 18, and 20, and I'm going to add them all, okay, and that would equal 80. Then I'm going to take that 80, and I'm going to divide it by 5, because there are 5 numbers, and I would get 16. That means the average or the mean age in this would be 16. Okay? The median is simply the middle number. So that's why we want them in order also. So the middle number here is 15. See that? And so the median here for the answer would be 15. The mode is just the number that occurs the most. In this one, it's not too hard to figure out, right? We've got 2 15s. We don't have 2 of any other number, so it's 15. But realize if I had 2 18s in here also, then we would have 2 modes, and it would be 15 and 18. But for this example, our mode is 15, the same as the median. And then our outlier is the furthest number from the median. Okay, and this is where absolute values come in, okay? If you remember what absolute value is after all this time. So in other words, we're looking at, this is our median, right? And we're looking at this number. From here, it's 3, right? And then we're looking at our largest number. From here, it's 5. 20 is the furthest from 15. So our outlier is 20. We identify outliers because oftentimes we may have a number that's way out. Say I was comparing ages here, and I had a student who was only like 5 years old in this class. That would be definitely an outlier because it would be so far away from the median number that would throw off our mean. Okay, guys? Okay, so that's these. Make sure, I'll step aside real quick, make sure that you pause this if you need to and write all this information down. Okay, so now we're going to look at another example. Okay, now what this is Margot and Ravi, and they went through and they're trying to convince their parents that they should be able to have a later bedtime. They don't need as much sleep. Okay, and so what they did was they took a bunch of information from different students. They polled different students to find out how many hours of sleep did they get. If you notice, the first thing I want you to look at is they were saying that most of the students were getting between 9 and 9.5 hours of sleep. Okay, so our number line is going like this: 8 hours and 15 minutes, 8.5 hours, 8 hours and 45 minutes, 9 hours, and so on. They were saying most of the students got between 9 and 9.5 hours of sleep. So what they did was they put this in what we call a box and whisker, okay? And so the way the box and whisker is this right here, these lines right here are median numbers, okay? So no matter how many people they polled, the median number was found to be 9 hours and 15 minutes. Okay, that's what this represents. So this is 9 hours and 15 minutes, okay? So they went through and figured that out. And then what you have to understand is each one of these whiskers is 25% of the people that were polled. So this is the bottom 25%. So right here with Margot's, it went from 8.5 hours was the shortest amount of time that somebody got sleep. The longest amount of time that they polled that they got sleep was 10 hours. Okay? 25% of the people were between 9 hours and 45 minutes and 10 hours. That's why this is here, 25%. Another 25%, the lowest 25%, was between 8.5 hours and 9 hours. That's another 25%. And then this portion, the box right here, represents 50% of the population, 50% of the students polled. So here's what you want to recognize right away, so that we know that their statement isn't true, that most of the people landed between 9 and 9.5 hours. Because their 50% right here of the population is larger than their smaller area, okay, than the area they claimed where most of the students were. In order to have most of the students be between this range, there would have to be more than 50% in this range. If you notice here with Ravi's, it's even more warped. See this? We've got a huge midsection, okay? And this is our inner quartile median, okay? That's what that's called, the inner quartile median. And I'm going to go through that more in the next lesson, okay? So there, as long as the inner quartile median, which is always worth 50% of the population, is bigger than this section where they're claiming most of the students are, then we know that their statements are false, okay? And that means that there's no way they're going to win this argument that they should have a later bedtime because most of the students get between 9 and 9.5 hours of sleep. Okay? So that's that one there. All right, that's from example 3. Make sure you look that over. Okay, so one last. All right, so this is Excel number 5. Now, you're going to find there's not a whole lot of Excels on this. All right, so you're going to want to make sure that you take your time on each one of them and do ones over that you need to. The main thing I wanted you to look at here is this is about a business going through and polling people and finding out if their customers are satisfied with their business, okay? The hardest thing about this is they've got systematic sampling, they've got simple random sampling, and then they've got convenience sampling. And if you don't know what those are, then it makes this difficult, a little more difficult. So I'm going to explain that real quick. Systematic sampling would be if you went through and said, okay, we're going to systematically go through and we're going to just poll every third person that walks into our store. Every third customer we had, we're going to contact them. We're going to see if they're happy with our service, okay? And so then it ends up being a little less biased because it doesn't matter who it is, you're going to poll every third person. In this poll, what this 81 over 200 means, it means that they polled 200 people based on that systematic sample, and 81 of them were happy with the business. They figured out that's approximately 40% of the customers, okay? Then they did another one, which is a simple random sampling. Simple random means you just call all the customers depending on whoever they are. They don't care when they came in the store. It doesn't matter. It has to be totally random. And the thing that's hard about that is you always have people that are biased that are doing the polling. Even if they don't mean to be, they're biased. For instance, if you're down at the mall and you go through, and this is what we're going to hit next, convenience sampling, because there's a lot of people at the mall. So you go to the mall and you say you're going to do a random sample of people that are coming in to find out if they appreciate the business there at the mall. But if you're young, you may only talk to people that are young like you are. Or you may only talk to older people, or you may only talk to men, or only talk to women. And so your polls become biased. So having a simple random sample is very difficult, okay? In their simple random sample, however, they sampled 1,000 people. And they figured out that 506 of them were happy with the business, which was approximately 50%, okay? This convenience sampling is like what I just said. You go where the people are. So if you're at the mall, there's always people coming in and out of the mall. If you're at the grocery store, there's always people coming in and out of the grocery store. So they went there and they just sampled people as they went in and out of the store. There, they went through and sampled 500 people. 297 said they were happy with the business, which is approximately 60%. Now for XL number 5, the problem is they're not taking in a lot of these possible biases to determine which one would be the best sample, because that's what they're asking you, which one would be the best sample. The main thing they looked at was this. They chose this one because they sampled the most people. The greater the population you sample, the better possibility you have that it would be accurate. So that's what they're looking at. Okay, guys? So hopefully that helps with the XL number 6. Make sure you ask questions over anything you don't understand. Remember to take your notes before you go through and do the XL. So you're going to go through, watch the lecture, take notes on it, then watch the examples, then go through and do the XL. And remember, you can do the XL as many times as you like. Okay, guys? All right. Ask questions if you need it.